Hello everybody, and welcome to the first episode of CeeviewStories, where each episode will cover a key Ceeview feature. My name is Guttorm Husveg, and today's episode has been titled When Ceeview Met Automation, inspired by the 80s movie When Harry Met Sally. While not as entertaining, I still hope the topic covered here will make your day slightly more interesting and efficient. As for most of us, my day holds its fair amount of boring tasks, like taking the dog for a morning walk or cleaning the kitchen. And even at work I'm not safe against tedious activities, searching the inbox for mails that really needs attention or keeping my timesheet up to date. In an attempt to reduce the amount of boring jobs we all need to do, we have introduced the automation module in Ceeview 2.1. While it may not yet be able to take the dog for a walk, it can automate many tasks and thus free some time for more creative activities. The new automation module in Ceeview is the result of many customer requests and was introduced in release 2.1 just after the summer holidays this year. Using Ceeview automation is easy and fairly straightforward. And before we dive into the fun part, let's firstly briefly look at what automation is and how it works. Defining an automation job consists of two distinct parts. Firstly, defining when an automated job should be executed. Either it can be executed based on state changes, or it can be triggered by health changes, or it can run on a timed schedule. Secondly, we need to define the steps required to manage the situation. Typically that involves things like gathering data and decide if further action is needed, perform the actions required to fix the situation, for instance starting a service, stopping a process, etc. And finally, notify interested parties regarding the situation and what has been done about it. So how can Ceeview automation be your friend and assistant? The following demonstration will illustrate how Ceeview automation allows you to automate typical well-defined tasks. And our examples uses automations triggered by health changes, but the same functionality is of course available for state and time-triggered automations. As this session is about creating automated jobs being triggered by health changes, we need some kind of health to trigger the automation. We don't have any here at the moment, so let's create a monitor. We'll be creating a system monitor, which is one of the more basic monitors. It will be monitoring only my machine, and it will only be monitoring the CPU usage. So we'll skip monitoring of both memory and disk. We'll configure the monitor to start reducing health of the machine when it reaches 50% CPU usage, and it will reduce the health to critical at 80%. Then we'll create a monitor, and we should see that the machine already has a health index. It should be 100. Yes, and as we see here it is 100, and it's the 100 index is from the system monitor, and on the left hand side we also see that the aggregated health is 100 since we only have one monitor. And on the home page we can see similar information. The aggregated asset health indicates one OK machine. We will create two sample automation jobs in order to demonstrate Ceeview automation today. The first job will be a fairly basic one, while the second one will be somewhat more comprehensive. The first job will actually use only one type of script, the action script, while the more comprehensive example will make use of all of the three scripts: data source, action and post. Let us talk a little bit about each of the types of scripts. The Datasource Script. The Datasource Script is normally used to analyze the situation or the scenario which has triggered the automation job. Gathering information, like for example in our demonstration today, it will gather a list of processes which needs to be handled by the action script. The Datasource Script is executed only once, and it produces as output a list of maps or entries. In our demonstration, it will be a list of processes or process entries, and each entry will have the process ID, process name, maybe a little bit more information about the process. This list of entries is passed as input to the action script. And the action script is the only mandatory script, the only one which is strictly speaking required in order to finalize or create an automation job. The action script is executed once for each entry in the input list. So if I have 3 entries in my list from the data source script, the action script will fire 3 times. And in our first example, we will only use the action script. Each time the action script executes, it appends an entry or a map to the list, which is its output argument. And this list of maps or entries is passed to the post script. The post script is executed once only and is normally used to summarize the actions that have been taken during the automation job. And sending this summary to users using, for example, email, or to send it to Ceeview users or Ceeview teams using Ceeview notification. Our first demonstration is based on a scenario where we have a machine with a runaway process. We need to identify the process causing the high CPU usage and evaluate if to terminate this process. We want this action to be triggered by a reduction in health for the machine. And there will be additional criteria for terminating the process. One of them is that high CPU usage needs to be one of the reasons for why the health of the machine has been reduced. Also, we have placed an additional criteria. The process's command line need to include a string annoying. That is basically just to protect us from killing processes, which is important for us. Right, so now we have a system health monitor, and we need an automation job which can be triggered by this system health. So let's start creating it. A suitable name first. Health triggered demo sounds good, and a description. A fine automated job. As earlier mentioned, we can have various kinds of events trigger an automation job. We are going to stick with health, but we could also have had service model changes as well as on a schedule. I want my job to be triggered if health goes below, reaches 80 or below, and I wanted to apply to the system health monitor. And I need to define what is going to happen when the job is triggered. Let's test it first. Okay, an empty result indicates okay. What happens if my script is invalid in some kind of way? For instance, say I misspelled in the for loop. Test it. I'll get a message indicating the error as well as where in the script the error is. Okay, let me test it again. No, I've done it right, and I'll save it. And I'll revisit the automation job in order to explain what happens in the script. The first part here is logging or tracing information which I send to a file. It's purely for debugging purposes. The first part of real interest is here, where I loop through all the reasons belonging to the event that caused the automation to start. And I'm searching for one reason indicating that there is issues relating to CPU usage. If I find such a reason, I set the variables CPU hogging to 1 or true. And in the next section, I will, if I found a CPU hogging problem, I will use a Ceeview extension, the list processes, to get all processes executing on the machine, and for each of them again I check whether the CPU usage for that process is equal to or larger than 20%, and if the command line contains the string annoying. The latter part is purely there because I don't want it to kill any process on my machine. In my case, for instance, I have the recorder for this session is using quite a lot of CPU, probably more than 20, and killing that would kill this session, and I don't want that. If I find a process I want to terminate, I use another Ceeview extension to Groovy, automation stop process, to kill the process. I make a note of the process ID and name, add it to a list, and I continue looping through all the processes doing similar. And finally, I return the list of processes I've killed out of the script, and I can actually see this this argument after the automation job has been executed in a log, which I'm going to show you in a moment. So that is the script. I didn't activate the automation job last time I created it, so I'll do that now. Okay, now the automation job is ready to execute if it's being kicked by change in health. So let's have a look to see what kind of CPU usage we have. As you can see, it's just below 40% in total. So, and I'm checking for 50 or higher. So I'm not going to be. I'm not currently not in a problem situation. So I'll generate a little bit of extra load on the machine, start my problem process. But first I'm going to change view. So now I see my machine here, and it's behaving perfectly, has health 100. And I'll start increasing the load CPU usage by my problem process. As you can see, the top process here is now starting to use more CPU. It's currently using about 50%, and the total usage is well above 50. It's close to 90%. So in not too long, the health of my machine should drop somewhat. Ceeview, or my installation of Ceeview, has been configured to check I think it's every 60 seconds. So within 60 seconds I should see this system health dropping down from 100. And there it dropped down to 49. That should have kicked the automation process. Let's check if that's true. At least we can see here that my annoying process has disappeared. So that seems to indicate that the automation has run. Here we see the first entry in the log for this automation job. It executed a few seconds ago, and it returned this data, an annoying CPU hogger, which was the one we saw in the task list. So it has executed, and the task list indicated that it had been killed, and I also observed it disappearing from my screen. So it worked as it should. If we check the health of my machine, we see now it's back to 100 again. We can have a look at history for health. It's this last part here. So here we had the problem situation, close to 90% CPU usage in total. Then the job was killed and the health went back to 100. Right, so that was a simple automation job, basically detecting a problem, terminating the process, and that's it. The second demonstration is based on the same scenario as the first demonstration. We have one or more runaway processes. We need to identify which processes this is, stop them, and possibly restart the processes. And to finish off, we need to inform a group of people about the actions taken. An additional criteria for this demonstration is that it will demonstrate the use of all of the Datasource action and post scripts. As for the first demonstration, it will be triggered by a reduction in health for the machine. And we will use the same criteria for why a process should be terminated. And in this scenario, any process that we terminate, we will attempt restart for. The notification consists of two parts. We're going to send a mail to a specific user, and secondly, we are going to send notification to a Ceeview team. And we are going to use Ceeview's mechanism for notification. Okay, so let's get started creating our second automation job. Let's give it a suitable name. And a description. Still triggered by health, and the same threshold, 80, and same health monitor. So we are first going to have a Datasource script. I'll go through the scripts afterwards. Secondly, we need the action script. And finally, a postscript. So let's start with the Datasource script. We recognize this part from the first demo. It's basically looping through all the reasons belonging to the health change that triggered the automation job. If we find a reason indicating issues related to CPU usage, then we continue. We execute the Ceeview extension to Groovy, list processes, and search for processes which use 20 or more % CPU and which have annoying CPU hogger.exe on its command line or as part of its command line. Contrary to what we did in the first demonstration, we now just append the information about the process ID, the name and the command line to a list of process entries, and this list is going to form the input to the action script. So at the end of the Datasource script, we return this list of process entries. Then over to the action script. Remember that the action script is fired once for every entry in its input list. The input list entry is the argument data. And once the action script is entered, we find the process ID and use the Ceeview extension, stop process, to terminate it. And then we log that we have terminated the process. Secondly, we build a command line, or we build a command to start the process again. It's basically this in this example is just a copy of the command line we found in the Datasource script. We use another Ceeview extension, start process, to start the process again, and we finally create an entry which holds the name and the command line of the process we have first stopped and then started, and we return that here out of the action script, and that will be appended to a list, to the list of entries which will form the input to the post script. So that leads us to the post script down here. The post script first uses a Ceeview extension send mail, and it sends a mail to a given user with a subject and a title, a body, which holds this text, and to it we append the content of the input argument. And as for the action script, the input argument's name is data. And data will be converted to toString automatically. So we will see when we start running the automation job what the output will look like. After having sent the email, we send a notification using another Ceeview extension, send to team. Notification sent to team uses Ceeview's notification system. We send the message to a demo team, much the same as for the mail. It has some kind of header, forced restart of processes, and a body which includes the input argument. The mechanism used to send this second notification sort of depends on how the notification has been configured for the various teams. This team, the demo team, actually has notification configured to be executed using both mail and the internal inbox of Ceeview. We'll see that in a moment. Right, so that is the 3 scripts we're going to use. Let's just verify that there's no issues here. Good. And then let's run the action script. Fine. Currently there is no test mechanism for the post script. So finally we need to activate this script, but before that let's have a look and see if we have what kind of process we have running. This is the 2 potential candidates for being killed. Currently they use hardly any CPU, so they wouldn't be killed, but what we are going to do is to activate the automation job. Then I will trigger these 2 processes, an annoying CPU hogger and an evil twin of the annoying CPU hogger, to start using lots of CPU. And after a while, approximately a minute, the health of the machine will change triggering the automation job to run, and these two processes will be terminated and that started again. So let's see if we can get this to work. I'll activate the job like that. Everything is nice and green. We can check here to see that what happens with the two annoying hoggers. We'll start making them use lots of CPU. Yeah, they started consuming more CPU now. I'll make them use a little bit more. Right. So now it's just to be patient for a few seconds, and we should see that the health changed as it did now. See the health changed to yellow. And we also see here that the processes changed, has dropped in CPU usage again. And if we had made a recording of the process IDs, we would have seen that they now have a different process ID, both of them. So they have actually been stopped and started. Alright, so how can we verify that this actually has happened? Well, one way is obviously to look at the automation job itself. Here we see that it was executed, and by clicking on the job or the result of the job, we see which processes has been handled. So it's the annoying CPU hogger and the evil tween as well. But we configured some notification and mailing, so let's see if we can find that. Let's go for the email first. Here we have my inbox. I've got two mails here. This is the email box for guttorm@husvik.net. We got two mails, and the reason for that is that we've sent one mail directly using email, and we sent one notification using Ceeview notification, which actually sends mail as well as sending a message to the Ceeview inbox. So that's why there is two mails here, because I got one directly and one through Ceeview notification. So that leaves us to check the inbox. And here we have the notification in the Ceeview inbox. This concludes the second demonstration, and I hope you'll find the Ceeview automation both powerful and useful. Well, that was a brief presentation of Ceeview automation and how to use it. Hopefully you can use some of its features in order to make your day more efficient. And while today's story is over, please join us for the next episode of CeeviewStories. It is titled Dr. Logman, The Power of Data, and is loosely based on the lost tapes of Doctor Who and the Power of the Daleks.